And thank you so much for having me. And thank you so much for having me back. This is my second GDG, and I love how you're so generous in the introduction every time. Hey, if somebody here wants to start their own GDG, but having presented a handful of these, well, I'm going to say some nice things that I probably shouldn't, because I think some other GDG organizers are here, but this has always been, for me, the one that's the best attended and really the most powerful of the GDG communities. So just thank you for having me back. Let me share my screen. I'm going to do my best to keep one eye on the chat as we go. So please feel free to just jump in the chat and ask questions, but there are going to be times, just given I'm on the road at the moment, I'm not at home, so I don't have my big screen here, and I don't have my two screens set up. I'm just on my laptop. I'll do my best to keep on switching back and forth.
And I'll for sure watch the chat. So
thank you.
If you can focus on the presentation, I'll mind the chat. So let's divide it that way.
Oh, perfect. Ooh, I appreciate that. That's going to make it a lot easier. Oh, I like that. So I brought slides. So I guess Jim, you asked me to give a brief bit of background. This is my second time as a founder. I started a company called Big Switch Networks back in 2010. We were one of the very, very first companies doing software-defined networking. We were acquired by Arista right before the pandemic. I'm very proud, actually, under the Arista brand last year that my old product lines just passed the $1 billion mark. So I think that's gone very, very, very well. After we were acquired, I went to Google. I was the senior director of product management for one of the two big Kubernetes teams. I had all the Kubernetes Advances Services. And that's really where the idea for RunWhen was born, was while I was on the Kubernetes team. And I think, now we're just starting to see, I'll trace a little bit of history, not about RunWhen, but about this category that we're in, AI SRE. I just think this area is super exciting. I mean, I think that this is, I think this could be as big of a deal, if not bigger, than Kubernetes. If you are either practicing SRE, or if you are kind of SRE adjacent, whether you're in DevOps or platform engineering, in the chat, please give a quick yes, I'm here. And I would just love to hear from you. Please interrupt with questions. Please interrupt with comments. And especially, I put up a LinkedIn post earlier today where I believe that people from an SRE background who are picking up coding with AI right now, I put this prediction. I think the compensation will rise by at least 30% here over the course of the year, because these roles are going to become some of the most powerful roles in all of engineering, and I feel like I'm seeing it happen. So if you're there and if you're picking up AI coding, I just think you're in an amazing, amazing place. That's my preview for, I have a strong opinion. Is AI coding going to be good or bad for SREs? I'm going to start there. I'm going to talk a little bit about the history of AI SRE and a couple of the core design patterns. I'm going to talk about, hey, if you're building one yourself, here are the design patterns that I think work after about 2 years of learning. And then I'll show a couple of quick demos of how we use our own. And I'm going to show actually an incident that we had about 6 hours ago. Kind of just lucky. And I'm going to walk through exactly what happened. So first of all, if there are any questions before I get started, pop them right in the chat. Otherwise, I'm just going to start rolling.
Kenny.
So, will SREs be able to surf the wave or get crushed? Here's some stats from our organization, and I have shown versions of this slide to, I don't know, probably 70 or 80 engineering leaders. And I think this is just like a pattern across the whole industry. When we first started doing AI coding across our team, we had about 20% change in lines of code per month. But other than that was like a big change. That felt like a big change at the time, but looking back on it, not all that much changed. We felt it, but not a ton. And there were all these posts, about a year and a half ago or so about, but we kind of passed a lot of them off as baloney. We then made 2 changes on the dev side in our team, and things went wild. As soon as we put in AI code review into our pipeline, And as soon as we put in AI adversarial testing, the lines of code per month went up by 10x. So the increase in lines of code per month over baseline went up by 10x. I mean, I just want to pause there. The velocity of code change was completely different once we put in those two things into our engineering process. And the storyline that I think a lot of people here probably are seeing, hey, when we're in AI coding phase 1, basically our most productive engineers, our top tech leads, wound up spending so much time reviewing other people's code that they weren't really heavily contributing. As soon as we put in AI code review and adversarial test harnesses, then they started contributing, and they're 10xers, and all of a sudden, wham, huge amount more code. Bugs dropped through the floor, and specifically bugs per line of code. I am firmly convinced that AI coding produces vastly fewer bugs than human coding, and we have the numbers to prove it. But we're producing so much more code that the number of incidents per month also went way up. So while lines of code per month is up 240%, incidents, Sev1s went up 15%, and Sev3s, 4s went up by 50%. And for any traditional SRE team, this slaughters the team.
Yeah, that's bad.
That's
bad for them.
We don't work with any team that got 50% more headcount.
No. I'm on a bridge every day, all day.
That's exactly it. That's what life looked like. And as soon as organizations click over from AI coding phase 1 to AI coding phase 2, I mean, we feel it amongst our customer base. Yeah, and it's instant. It's like a single PR, and suddenly the world has changed. So I think we got to fight fire with fire. I really love it. I met a great, probably one of the leading infrastructure leaders here in New York, and I love the way that he put it. He's like, gosh, AI coding is just this amazing thing. So now what can my SRE team do with it? And that's what we're going to talk about today. Before you charge out and start saying, all right, hey, I'm going to start doing, either I'm an SRE and I've coded in the past, or I'm going to staff some people on my team to start building an AI SRE. Let me just show you. I'm going to show you the 2 historic design patterns and why they're failing, and then why I think there's a new design pattern that's emerging that is just much more powerful. This about a year ago, give or take, this is the design that you started to see come out of vendors over the last 3 or 4 months. This is kind of the design that you see for most teams that are doing DIY. You have PagerDuty feeding in alerts. You have an agentic loop that's got MCP servers that are doing logs and metrics queries. And then for every alert, you spit out a root cause story. And it's pretty useless. These projects get to demo scale, and they roll out into production, and they flop. And I think that's actually given AI SRE in some organizations a bad name. And let me show you why. So if you're generating 1 to 3 hypotheses per alert, and your hypotheses on the root cause are only about 70% accurate, 70% accuracy with this design, by the way, is hard. You're not actually saving anybody any time. You're actually generating more root causes than you are alerts, and that's not all that great. You're generating a heck of a lot of large observability cleanup projects that nobody really wants to do. We'll talk more about that in 1 second. So in a microenvironment, like a single person on a laptop, this is fine for personal troubleshooting. When we rolled this out across our environment, it just didn't save any SRE time. So whether it was expensive or not expensive, it just didn't matter. And none of these really get rolled out in serious organizations at scale. They're just not accurate enough. So it makes the alert noise worse. And why? We'll come back to this a couple times. LLMs don't know how all these words relate to each other. Humans do. LLMs don't. And so minor differences in wording between what shows up in logs and what shows up in metrics confuses the heck out of even the most advanced LLMs. We call it the entity resolution problem. Are these 2 different names for the same concept or not? And our industry is filled with entity resolution problems. And then we have how are these observations related to each other? Beyond entity resolution, now, okay, even if we can resolve the entities, a human very often has a really good intuitive feel for what we call it a dependency graph, for which services are dependent on each other, for which services are dependent on which infrastructure, especially when somebody's been an SRE in an environment for more than a couple of months. There's a lot of intuition there that an LLM doesn't replicate out of the box. And the third thing that's really hard for AI SREs is what's new versus what's normal. And if you just think about it, somebody's first, signals versus context, exactly. And we've got a bunch of publications on this, and the new versus normal problem is hard. So the industry, in response to the first two problems, you find more and more, both vendors and some of the larger teams that are able to staff 2, 3, 4 people, kind of came up with what I call phase 2 of AI SRE. An alert comes in, you have an agentic loop. It's doing some CLI access or some API skills generally to pull up. Everybody starts with kubectl, gcloud, CLI. It's still doing the MCP calls to do logs and metrics queries. And then there's this really diverse approach to building dependency and knowledge graphs. And I would say this was kind of state of the art about third quarter last year amongst vendors. And in DIY projects, you see that mostly starting to show up first quarter this year. A few of the larger banks started doing these DIY November and December last year, but for the most part, these were kind of first quarter this year. Now, 60 to 90% accuracy is a big improvement over the last one. And that's why I think everybody jumped on these projects fairly quickly. But I want to call your attention to, you're doing so much more work in the LLM that these are typically consuming about 75 to 150,000 tokens per alert. Now, it doesn't seem much when you think about one alert, but at 90% accuracy, at the very high end of the range, if your team had very clean telemetry to start with, 90% accuracy, you just start being accurate enough to actually save a little bit of SRE time. You still typically are only used by teams that have other tools. So you're getting used alongside a dashboard. You're getting used alongside a bunch of by-hands metrics queries and hunting. And that's the high end of this range. So 90% accurate is when you just start to get to be useful. Your RCA accuracy depends very heavily on entity resolution, very heavily on your dependency graph, which means in some environments, this stuff works, and in some environments, it doesn't. And it is incredibly difficult to predict in advance. But very often, I consider this across anything but the three leading vendors here. I'd say most of the industry is still kind of coming in this phase 2 AI SRE and climbing their way from 80 to 90%. In our environment at phase 2, it helped our SREs as a personal tool, but we couldn't release it to our developers. It was too confusing and not quite accurate enough, even at 90%. For an enterprise app team, the ones that have released this, they start to get into token cost problems, because if you're using a premium model that actually is going to save people time, you're kind of doing a trade-off of, if you have noisy alerts, you can pretty easily start racking up LLM bills that are about half to 100% of the cost of actually adding an SRE to the team. And that's a tough trade. It's not clear that that's a trade that every team would make. And then for enterprises that look to roll this out, exactly. This is token maxing. For enterprises that look to roll this out across the entire enterprise, what we saw over and over again was, hey, it just doesn't work well enough in that enterprises in all of their environments. So some would work well, some wouldn't, and the token count was just high enough that this is just a very, very, very expensive way to go. But this is sort of where I think the industry right now is just coming out of this phase, especially the leading vendors. But this, everybody, 6 months ago, everybody had some innovation on how they were going to do the knowledge graph. And it was like every couple of weeks, you'd see somebody talking about it. And everybody would say, oh, wow, well, this particular set of CLI and API skills really matter. Stretch on specific AI models, we use an expensive one, so we use Opus, and we use a cheap one, so we use GPT, the cheaper the GPT-4s and the cheaper the GPT-5 ranges. We use a mix on our side. We use a mix of the two, but we actually experiment with a whole bunch. We've experimented with Quen models and Kimi models, and they're over and over. We find the more expensive models are really, really what you want for any of the foreground processing, and then you can go a little cheaper for background processing, but I'll get to that in a sec. I think right now most of the industry is sitting here in phase 2.
So
Incremental
Kyle,
progress.
On the implication side, and on the findings, that's like the best case, 90%. Clean telemetry. Is it those teams, the token cost can be that high? And what is the token cost for a team that has dirty telemetry, that fires lots of alerts that you don't really want to feed through and spend tokens on? Do you have any idea how bad it could get? Like 3 or 4 FTE, you turn something on that's not working well?
We found the token count doesn't seem to correlate too closely with accuracy.
Sure.
So if somebody has messy telemetry, then the accuracy goes way, way down, but the token count is about the same as if somebody has perfect telemetry. If somebody has perfect telemetry, they get closer to 90% at 75 to 150K tokens. If they have messy telemetry, they're like 60% accurate with 75 to 150K tokens. You can't quite throw tokens at messy telemetry with these designs and have it do much. You can try to add more and more.
Of is the so you're in an environment that's messy, not from the telemetry, but the number of alerts that are coming in. And I think you might have mentioned it earlier, like I'm seeing so many things that's going to my LLM model. It's costing me so much money. Now we have to go back and just spend time cleaning up when we want to trigger an event to be analyzed.
Yep. All these models, the logic all started off with an alert, and that kicked off an agentic loop, and that was what phase 2 was. And I can point to there now. I'll put it actually in the notes afterwards. There's sort of 3 or 4 open source projects that look like this architecture. So with an open source project, you can just try it. You can validate our findings quite easily. A lot of the observability vendors are actually still stuck on this at the moment, and so you do see the same. And you see that's why you see kind of pricing at like $50 and $75 effectively per alert to run it through these LLM loops. It's just because the token counts underneath are so freaking high. So I think that this is where observability vendors are, and I think this is where a hunk. But there are a couple leading folks and leading DIY projects in-house that are now moving on to phase 3. And I want to show you what phase 3 looks like. Phase 3, we're seeing 95 to 98% accuracies, sub 1,000 tokens per alert. Just completely different ballpark.
Yeah.
And this is where the industry is going. If you're building your own, if you're just starting out, this is the opportunity, I think, to do a very, very big leapfrog. And the slide looks really complicated, but I'll just break it down bit by bit, and then I'll show kind of examples of each. Here's the step 1, and it's different. Instead of starting with logs and metrics, you start by building diagnostic scripts. This is the big change. But it's a different way of thinking about it, but I'll show you kind of how fast that is. And the real core insight is that you're building a diagnostic script that, sure, hey, run the CLI command and tell me what it said, but also grep the CLI command and look for a couple strings. And if those were there, then give me a structured output to say, hey, this is an error. In our particular case, we call it an issue. Hey, grep the output, show issues. What that lets you do is that lets you offload a huge amount of processing to decide, hey, there's a lot of stuff that you don't process with an LLM. And you can do this with a Claude skills base. If you're clever about it, you can do it a lot of different ways. I'll show you the open source library that you can use as a starting point if you like. Everybody starts with kubectl, gcloud, curl, SQL, and logstack, tracegraph. There's like some basics that everybody gets through first, and then you can add more and more on top of that. And the gist is, every time you run a diagnostic script, you want to return an OK or an error code. It sounds incredibly simple, right? Stuff that we've been doing for a long time, but I think this like 1990s style of diagnostics is just about to come back in a huge way. You run the diagnostics either as cron jobs, or you can kick them off yourself. You run them in response to alerts, and you build up a big database of, here are my diagnostic script executions, and here are the error codes, and here are the OKs that were coming back.
So diagnostics, build a baseline. All right.
And after you can probably start to see the logic to say, hey, if the error code comes back okay, do nothing. If it's an error code that we've never seen before, now start kicking it up to an LLM to try to figure out what to do next. But if it's an error code that we've seen before, we can probably go back to the LLM. We can probably go back to some cached results because we've already processed, when I see this error code, what should I do next? And what you see is these longer and longer chains of your diagnostics will very, very, very naturally emerge. I'm hoping most of the people here have heard of the Carpathy LLM Wiki approach. There are now some really great open source implementations of it. We did that design starting about a year ago, give or take now. We were both elated when he made it public, as well as kind of crushed. If you haven't read about the Carpathy LLM Wiki, the gist is, this is Andrej Karpathy, the founder of OpenAI. You put a whole bunch of documents into a directory, and then you have your LLM constantly sort of crawling its way over the documents, creating summaries, generating topics out of them, linking the documents, and you have an LLM generate a full wiki about all of these documents that you've put in. And now your agents are reading a wiki about the document, and it makes for incredibly accurate question answering. We use this to do all of the dependency graph, all of the knowledge graph work. You no longer need a CMDB underneath. I'll show a couple of examples. It is so eerily, crazily accurate. And all that you need to do is just mine the results of your diagnostics. Crawl samples of them, and just say, hey, what did I learn? What did I learn? What did I learn? It's vastly more accurate than any CMDB, and you get these really incredibly insightful dependencies that come out of it. And I'll show some here in examples. I mean, we've just seen wow over and over and over from this approach. And the last thing that you can do is, since you're using this Carpathy LLM Wiki approach, hey, anytime you want, you can ask Claude, hey, could you just write up a one-pager for me on X? Hey, can you summarize this part of the code base for me? Summarize all the different services and their dependencies. Looking at this part of the code base. Hey, can you tell me the probable errors that I'll get over in this part of the code base? Hey, can you summarize this last troubleshooting session for me? Give me a paragraph on it. Just drop that into the LLM Wiki as well, and your agents pick it up and pick it up and pick it up. So you can do a lot of human coaching without any change whatsoever to the architecture. If you were going to build your own AI SRE, I highly recommend starting with this design. And now at the end, you have something very accurate. Yeah.
Kyle, before we get to the that last third of the slide, so going back to the scripts, the diagnostic scripts, is it we're manually building these scripts, or is there libraries of scripts, or where are people finding these the diagnostics that they should run?
We spent almost 3 years building out this massive library of these diagnostics. I am going to put these in the chat.
All right. So
hopefully that saves a lot of people a lot of time.
Yeah. I love this user's name is SSH. I didn't know I had an SSH server set up for the session, but connected.
And you can see that, I mean, here are just the categories of these. We have diagnostics in here. We also have some of the remediation runbooks in here. But yeah, feel free to roll through these as you see fit.
Nice.
And these are all structured, again, to emit both raw text as well as structured objects that get the accuracy way up and get the token count way down. Yep, Arun, that's exactly it. Kick the error codes up into the LLM, let them try to solve it, and cache their results. So that way, when you see the same error code for the 42,000th time, you're not burning any tokens at all. And then you can get creative to say, hey, okay, if I've seen these error codes before, but I've never seen them in this particular combination, kick that up to the LLM. You can play a lot of games about, hey, when you do code and cache, when you run code, when you make decisions out of your cache, and when you kick it up to the LLM to make a bunch of fresh decisions. But what turns out is that when you have noisy alerts, a tiny, tiny, tiny fraction of the alerts wind up seeing any kind of novel. You have an alert, you run 40 or 50 diagnostics, the chance that the combination of things that you see that's novel is very slim. On our side, we use we're kind of building for high scale. We have a pretty wild backend that's combines temporal, semantic, and SQL search. So we use a combination of 3 different databases on our side. I do think that's a bit of an implementation detail. I think there are probably plenty of other ways to do this LLM wiki thing. We've built for very, very high volume. So Kenny, to your point, no metrics, traces, logs into the LLM. Exactly. You only send the structured error codes and the error description into the LLM. Don't send. It's okay. You'll see plenty of tasks in here. Hey, I checked the log for stack traces. Here's a hash of the stack trace. Okay, the hash of the stack trace becomes an error code. That's totally fine. If it sees a novel error code, then it'll grab the stack trace, but don't just randomly dump huge amounts of logs into LLMs. Unless you have really, really good novelty keying, dumping logs into LLMs is the fastest way to burn massive, massive, massive amounts of tokens. You want to grep the logs first, and then send the results of what you've processed to the LLM. The first thing that everybody does is grep your logs for stack traces, create a hash to the stack trace, so that way that you use that as your novelty key, and then that's your structured object. Any other questions before I'm going to show what this looks like in real life?
It was a quick one from Rama. Does the LLM correlate the alert versus the previous incidents to a run book for the troubleshooting steps? And maybe that's where the LLM wiki is holding the run books on top of the other things that it's holding.
This is where you only go to the LLM when you see a novel. We call them issues, these structured objects that we raise. So I'll just use that terminology. We only go to the LLM when it's an issue type that you've never seen before. Which means the vast majority of the time, if you have noisy alerts, you never have to go up to the LLM at all. You're doing a lot of processing, but not with an LLM. You only go up to the LLM when you start to see novel issues and novel combinations of issues. It saves a huge amount of money on tokens because you need to worry about this stuff at very high volume. It also plays a huge role in accuracy, which I hope you'll actually, from the incident that we had this afternoon, I think you'll even be able to see it there. So as a starter, and I'll show you building a new one of these in a minute, but as a starter, just start with the massive open source library. Here's what our LLM wiki looks like. You can see directories. You can see the tasks that go in the LLM wiki. You can see notes that people just left in here to say, hey, here's some assumptions that I want to put in. And then you can see the LLM sort of, we're constantly mining this, we're constantly mining this. And so it's adding little entries by itself. And we're saying, all right, agent farm depends on Pappy. How? Here's how we know. I don't think I have it here, but we've had in ours, if I have time, I'll show it actually like in one of our environments. We'll get fascinating dependencies that you'd never see in a CMDB and you'd never even see in tracing. We'll get things like this particular deployment, our agent farm deployment actually depends on Argo CD, which is true. It's not that it depends on it at runtime, but if Argo CD fails, then the agent farm deployment isn't going to get new software images. And we've actually had that as an issue where we had an Argo CD partial rollout and then a huge incident. This was in our test environment because not all of our images were up to date. So we had a bunch of version mismatches going back and forth. So these are really subtle dependencies. We can see really interesting dependencies where we have two services that share a database table. We don't have that in our particular environment, but certainly we see it in clients where all of a sudden a version mismatch and there's what looks kind of like a data corruption issue. These two services never spoke to each other directly. They just happen to be reading and writing from the same tables. And this LLM wiki approach pulls that type of stuff up in a way that you'll never find from any tracing approach. Andrew, experimenting with offline LLMs at all, we basically find as soon as you do this approach for token optimization by raising issues, yes, it's more work in the coding up front, but it means that you can use Opus for everything. Use the most expensive, powerful LLMs because you're using so few tokens 99.999% of the time that you don't have to worry about it. And we do find the more powerful LLMs really do matter. Everybody on our team, I made a big deal of like, hey, I see what we're spending for our own use. Maybe we could save a couple $1,000 a month by, and we're kind of running a fairly large estate here, given that we're a SaaS service for a bunch of our clients. Some of our clients are self-hosted, some are on SaaS. But my team went up and howled. They said, no, we want Opus back. We want Opus back. We want Opus back. And for $1,000 a month, like it was kind of a no-brainer. If that bill had been the difference between like $30,000 or $40,000 a month, nobody would get Opus. So that's what the LLM wiki looks like. Structure it however you like. I haven't seen a diversity of structure. I can't comment on whether one structure is vastly better than the other, but I can say that the general design pattern of this LLM wiki means that we don't need CMDB data whatsoever. And there's a massive amount of useful data that's in here. You then can build your assistants. Here's the RunWhen implementation. You can build your assistants by basically saying, hey, look, treat this as basically like old school Linux admin. Give different assistants different rights over different directories. Some of them have execution, some of them have read, some of them have read only, some of them have read write, that they can actually write different insights back out into those directories. And all of a sudden we're out of the world of like fuzzy AI and we're into something that feels a lot like Linux admin. And it makes the RBAC model just incredibly easy. Give different assistants to different teams, give different assistants to different people, give different assistants different jobs. And the biggest difference between your assistants, sure, we have some advanced stuff for customization for those, but I think that's kind of an implementation detail. You're basically in Linux admin territory. It's comfortable. It's very intuitive. It's incredibly easy to troubleshoot. So huge wins on this front. I'll show you what this looks like in our environment. So show me all the tasks available for Pappy. You can see it's just going straight into, it's just going straight into the file system. It's not magic. And this going back, all of these tasks came from the open source library. So all of these, you can see that there's Kubernetes troubleshooting. You can see there's just fetching logs. There's looking for some event anomalies. You can see there's looking for application log patterns. So there's both application layer troubleshooting here, as well as basic Kubernetes troubleshooting. And look at horizontal pod autoscaler health. That's kind of an advanced topic, but it turns out to be an extraordinarily useful troubleshooting technique. A whole bunch of different remediations. We often customize these for clients, but a whole bunch of basic ones just come out of the box. Synthetic tests come out of the box to say, hey, let me just curl the URLs and just see if the thing is alive. And you can see in our model, I clicked the run button just so that we didn't have to wait here. You have it run the tasks and then have it read the results. And now this is where you get the incredible accuracy. You don't trust the LLM to do a whole lot of thinking. You trust the LLM to synthesize the results of a whole bunch of diagnostic tests that you wrote. They're not trying to do correlations that are very, very uncertain with uncertain entity resolution, creating error rates. With uncertain dependency analysis, those create more and more error rates. They're simply trying to summarize the result of a whole bunch of diagnostics.
Yeah, the way you have it, the way you have it broken down into mini steps that, if you were drop down in the 90s into a Linux environment trying to figure out what's wrong. You'd use the Linux tools and you check everywhere. Okay, it's okay? It's okay. And things are okay, I don't have to look at it anymore.
Exactly.
But the things that are not okay, now you're turning it into a known issue structure. And you can send that to your very smart friend, Opus, and have him try and figure it out.
This is the design pattern that, when you get this level of accuracy with this, I mean, it's clear this design pattern is the right one. I think it's just a no-brainer.
And for real SREs or any technical person coming to look at it, you're like, oh yeah, that makes sense. That makes sense. That makes sense. That makes sense. That's what I would have done anyways. Instead of taking a big blob of stuff, throw it into a magic box and have it kind of guess what the problem is.
Exactly. You can just read the raw script output if you like. Everybody kind of starts there and then like, oh wow, I'm never going to have to read this script output twice. Let's have the LLM read it for me. The script output is just sitting right there in the file system. you can read it as you see fit. Now, I think I want to swap over because I'm saying all of these things I hope somebody sees magical, but I hope somebody in the audience will think, oh, wait, hold on. We get, okay, so you get, I think what in the environment, I think in this environment, what we have about 1.5 thousand tasks. I can tell you there, out of those, there are 40 that are custom and all the rest actually came out of the library. So 40 custom ones, but still, you could say, all right, wow, does this mean that I have to write these 40 diagnostics? I'm going to show you something real quick. This is me with Claude writing a diagnostic and with our MCP server now. And I don't think, this was a hunk of engineering, but I don't think there's any massive secret sauce there. For the most part, with our diagnostic tests, we can one-shot it now. I'll just pause here to let everybody read this prompt, but that's it. This is how long it takes to write a diagnostic test.
So Kyle, while people are reading that, Arun had a question on the agents that you're using, if the agents themselves are stateful, or if the agents are just stateless workers that rely on that external state stored somewhere else.
Stateless, and they just rely on the file system. We tried like 5 other things. We tried to get so fancy. It got like incremental improvement, but spending time prompt tuning the agent to actually just do a better and better job reading the file system and thinking about deeply how do we structure the file system and how do we do the equivalent of symlinks. Had much more benefit than, I think we're pretty on the cutting edge of agent memory and we just gave up on all of it. I think this kind of approach, writing your own diagnostics kind of went out of fashion somewhere circa, at least in financial services, went out of fashion somewhere circa 2010. I think because doing a diagnostic like this would have taken somebody who knows the code very, very, very deeply, who's probably busy doing 10 other things, probably would have taken them at least a day to get it into a test environment and validate it. If there was any drift, then that one person wouldn't be needed for maintenance. We can load in enough context from stuff that we see already running in production that now it's just a one-shot, just a one-shot. That's it. And now I'm going to loop all the way back to that first slide that you saw. This goes into a little pipeline that's doing code review. And we've got 5 different stages of code review, because I think reviewing operational code is a little different from reviewing application code. Most of these diagnostic tests are only 100, 150 lines, but you still have 5 different layers of review. And then we do a little bit of testing on before they actually hit prod with some other stuff we talked about. But we kind of learned a lot from what made our developers so much more productive with application code, and we just applied that for SRE harnesses. I'm not going to go all the way down through all the reasoning, but this was a one shot that went straight into prod. I will show you one last thing. So I hope you saw that it was the usearch service that we were one-shotting there. So this was a thread from earlier today. It started with me. I noticed there was something funky going on as I was trying to prep for a demo. I couldn't exactly put my finger on it. So I just said, hey, show me all the new issues that you found in the last hour. Again, this is the structured object, and we can say, hey, here are all the new ones that we've seen before. So let's just ignore everything that's been going for a while, because I only started seeing this an hour ago. Let me pull up recent issues, run sessions. I found 11 open issues for the last hour. Prompt tune to your heart's desire. Everybody has a slightly different take on the user interface. I'm using the one that's particularly chatty. I found that's a little bit better in incidents, but we let users add a little bit of stuff in the system prompt if they wanted to be a little bit more concise. It's so personal preference that if you build your own, I strongly recommend that you let users configure their own level of chattiness, because nobody agrees. You can see, all right, while running check usearch indexing job health, I found 84 partial failed indexing jobs in the last 24 hours. During execution check usearch indexing job health, I found 50 stuck lost jobs. While I was checking the Neo4j database underneath, I found, an unexpected unique constraint missing. I'll keep on sort of rolling through this. What tasks should I run right now to get the current status? The nice thing is, since we're all task-based, we can just run this stuff again and check to see if novel issues show up or if old issues have now disappeared. We just have it read the same report. And now you can see the accuracy rate, again, because it's not doing a whole lot of guessing. It's just reading diagnostics that we've written. The accuracy rate here is through the roof. We can compare it to 30 minutes ago by comparing structured data to structured data. And if we want to go a little bit deeper, okay, then we can take all of the task output and feed it to an LLM. So you always have the option to actually burn a lot of tokens. But when it's human interactive stuff rather than in the background, now suddenly you're burning a lot of tokens per human investigation rather than per alert. And if you're burning tokens per human investigation, you're never going to run up the bills all that high. The bills only get high when you're pumping in tens of thousands of alerts to the thing, which a lot of people do. And this was pretty fascinating that you can see in 2 prompts, it came to something that I would consider to be pretty freaking esoteric. It also figured out that we actually, I think I scrolled through it at some point, restoring the constraint. Anyways, one of the things that came out, we actually had this constraint in, and then you'll see it's here in the output somewhere. I'll have to, yeah, anyways, it's here in the output, but it noticed that actually the constraint was in until April 8th. And then 20 days ago, a constraint left, which meant that our Neo4j performance has actually been degraded for the last 20 days in this environment, effectively while these jobs have been backing up and backing up and backing up. And then we just sort of draft a body for the ticket. And now, since we have all of this stuff in LLM context land, it's just going to draft a much better ticket than, I don't know about any of y'all, but I would just never have written up something like this. Yep, this has been detected continuously since April 8th. The missing constraint's the likely driver. So, I mean, this for us was literally just this afternoon. You can read the whole story. And anyways, now that we have all of this information with a very, very, very high-powered LLM, we can do a heck of a lot of reasoning across it and go back and ask questions, et cetera. And then we just sort of create a ticket.
Are we ending on a cliffhanger? Did the constraint, adding the constraint back, did it fix the problem?
The that's when I handed off and started getting ready for my next demo. So I haven't checked back into the team. But my assumption is that I could hand off this one pretty cleanly and move on to my next thing.
Yeah.
So Jim, that's everything that I brought except for one more thing. Everything you saw today happened in an environment where we actually stopped using any observability stack. We still use logs and metrics in prod, but everything that you saw here was in our test environment across all of our non-prod. We went from GCP stack driver to the Grafana to the LGTM stack. And then we went to self-hosted LGTM, and we just gave up on it across all of our non-prod environments. Nobody was using it anymore. Everything you saw today, not a single dollar was spent on logs or metrics. The tasks collect some logs directly from pods. They can pull logs directly from serverless. Beyond that, nothing else.
That can save a lot of money, potentially.
Yeah. Yep. When you can get the token count down, we're going from, hey, you need to do a massive observability cleanup, probably spend money on tracing, and then after that, you need to spend about a head count on tokens, to cutting the tokens down by 2 to 3 orders of magnitude. And there's a road ahead here where we just rethink observability to be agent first in a very, very, very deep way.
I wasn't expecting that as part of this presentation. A shocker. All right. So there's a few questions came in while you're showing that last slide. So yeah, SSH. Most of the diagnostics are already set up. New ones are created by the expensive LLMs. Ideally, resolution steps are divided up into tasks, including for the diagnostic tasks, but the person on call interacts with an LLM with MCP that has access to the resolution task. Like yep. That's kind of the idea.
That's exactly it.
All right. All right. Suresh had a question after that. I can see the SRE generating a lot of data. Is there a way to present the output in aggregated on an analytics dashboard with prioritized visualization and notifications? Any way to prettify the results, aggregate the results? And
I mean, happy to do a full, more commercial demo. We have on the commercial side. We chose to make it more chat than dashboard, but when you certain chats, it'll actually build the dashboard for you with a whole bunch of time series charts. So we can do things like give me time series of this issue over time, give me time series of all of the issues in this particular area over time. We just build them on the fly. We have a couple of dashboards
on demand.
Yeah, we have a couple of dashboards that we use a little bit.
Yeah.
But the stuff that our team wound up gravitating a little bit more is slash commands, the same way that you'd use them in Cursor or Claude, which are effectively really, really, really long prompts. I could show a few actually if you like. So that way the prompt is totally normalized. That prompt always brings up the same set of visualizations. And that prompt actually also brings up a set of analysis.
Okay, so you just charts on demand, but we like to look at it this way because our human eyes don't want to don't reorient it every time. I need to be recalibrated if you change the chart. So give it to us the same way every time with the new data.
Yep. Same way that we use Claude for what it's worth. We have PR processes and PR review processes that in Claude we just packaged up as slash commands. So we kind of figured that this is a pretty natural way to do it. If you want to see the same layout, you just have a quick slash command. It's the same page long prompt. You see the same layout every time.
All right, and then one from Arun. Since the system relies on documentation and runbooks before escalating to LLM reasoning for new errors, how do you handle incorrect or stale documentation? Is there a way to trace which document or runbook section influenced the agent's recommendation? So corrupted guidance can be identified and fixed.
So that's the read the Karpathy LLM wiki approach. That's what a huge amount of it is, that you're constantly ingesting lots and lots of text, lots of documents. You have LLMs that are, he's got a really, really thought through design where you're feeding them through LLMs in order to see, hey, where do you have cases where all these documents agree? And where do you have cases where these documents disagree? And where they agree, let those bubble up as facts. And where they disagree, keep those as lower down the hierarchy. Effectively, they're maybe facts, but they have much, much more uncertainty, and LLMs reach them much less often. So remember, we're running that not only across documentation, we're running that actually across all the diagnostics that we're running. Here, let me see if I've got a good visual. Here, actually, yeah, here, I've got a good visual. So, okay, we came up with this fact: agent farm depends on PAPI. How do we find that out? Do we find that out from documentation? Well, we find that out that in the logs, there are 47 outbound PAPI calls from agent farm in a single 15-minute window. We're pretty sure that these two things are connected. There's an HP, and the rest of these are sort of, hey, we found issues that were highly, highly, highly correlated. So maybe we weren't so sure about these, but given this piece of evidence, and given it's corroborated by all of these other pieces of evidence, we can be pretty damn sure that agent farm depends on PAPI.
So I guess the 10-second on that one, don't think of the LLM wiki as the wiki that you've used your whole life, where people just put stuff there and it never changes and it gets old. It's constantly being refreshed. It's still a wiki, but there are agents or tasks in the background that are constantly finding new information and getting rid of the old stuff. It's like everything is the latest.
Yep. Yeah. I like the way Karpathy, but it's like having a librarian constantly reading your wiki and maintaining it and keeping it up to date.
Nice. So Kyle, you might remember this from last time, and as if you guys still have questions, I know we're approaching the hour mark. If you still have questions, put them in there in the chat. We'll try and get to them. I didn't ask Kyle if he has a dinner or something else to run to.
I'll be around for the clients. I'll be around for the network thing, and I'm looking forward to. You didn't tell me there might be a tornado warning while we're at the flying saucer, but
Flying saucer, I think will be okay. I think that storms are supposed to burn themselves out tonight. It might rain a little bit, but my weatherman friend said, don't worry about it. But you never know. Texas, if you don't like the weather, just wait a minute. It'll change. All right. There's a non-technical question. It's a career question. So you've answered one before of, if you could go back in time and give your early career self some advice, what would you what would you tell young Kyle? But maybe some more general advice. I don't know. It could be any direction you want to go. Telling somebody, a younger self, somebody that's young, or even us older guys that are dealing with this explosion of new technologies. And trying to keep our skills up to date and marketable. Any career advice that you'd like to give us?
I knew you were going to ask it, and I was so tempted to go back to our old recording and see what I said before, but I'm pretty sure I didn't say this one before. Right before I went to, I was working for a couple of years, and right before I went back to grad school, I went to cooking school for 3 months.
Oh, wow.
And in my entire life and my entire career, nothing has paid off for me quite the way that cooking school did. And I think that we're in the most exciting, incredibly exciting time with AI. Like, this is the most exciting engineering moment. This is like the early days of mobile, when you kind of see something that is just so clearly going to change the world around you. But there are times when I'm like, hey, there's just so much uncertainty, and we're in a very economic, uncertain time that while it's exciting some days, the highs are high and the lows are low. I'm so glad in those low lows. If this doesn't work out, I'm just going to go be a chef. My best career advice is go to cooking school.
That's also the first time that advice has been given in this forum. But yeah, having those physical world skills to fall back on, something that gives you joy, gives you the ability to serve other people. No, that's that's great. I'm just looking through the chat here. Suresh is just giving some great prezo. And yes, there was a question about, is this being recorded? Yes, it is being recorded. It usually takes me a couple days. I always say by Monday, check back to the event page where you joined from. Scroll down to the bottom. It'll be linked there. It'll be on YouTube. It'll have the introduction kind of chopped off and go straight into Kyle, so you don't have to fast forward through the welcome section. But yeah, just check back. And even if you go back through our catalog and want to watch the last Kyle presentation for GDG Cloud Southlake, you could find it. I didn't memorize what number it was, but you'll be able to check it out and see kind of the great strides that have been made on the RunWhen ecosystem, from the idea and initial creation to now super streamlined for token usage, very understandable, does the job of gives the superpowers to your SRE team so they can really fine tune how they live in the environment, and maybe not have to pay an observability provider in the future. All right. Yes. So we'll close this part off with the presentation part off. Kyle, really glad you could join us. Thanks for taking the time to build a presentation, show us what you guys have been working on, giving us that thought leadership on how AREs can help, not AREs, AI can help your SRE team, but kind of that pattern of that you guys are following. I think you can apply that to other disciplines as well. Kind of that don't just feed a bunch of stuff into the LLM. How do you know what's going right? How do you detect the outliers? What's this new thing that's wrong? The things that have gone wrong in the past, how did we solve them? So it builds up your library of skills. I see a problem. How do I fix it? Okay, that goes into our fix it catalog. So just an ongoing smartening of the environment. Things that were maybe tribal knowledge in your brain are now tribal knowledge, but that tribal knowledge is now written down in a wiki, and the agent can read it, a human can read it. So that's fantastic. And yeah, really appreciate you coming and joining us tonight, and then joining us on Thursday for the social club.
Looking forward to it. Thanks again. I'll stick around for the networking session, at least for the first 20 minutes of it afterwards too.
Perfect. So everybody,